Right, so now down here I can write sort of my main code to run model. So this is just, I'm not going to use a function for this, but I could do. Let's say, so we need our initial conditions. So let's say initial conditions a naught or va naught equals, let's say we've got 1 cubic meter. I think that's about 1.0. Just make a note of, well, say we're talking about a bathtub, we're talking about the milk carton, so this is going to be about 1 litre. So our units are litres. Then b volume of b at naught equals naught. So I can say the c naught v d naught equals naught. I don't need to put units there. So that's my initial condition. So now I can work out how many time steps I need to run. So let's go time start equals 0, time end equals, let's run that. We said 1,000 seconds, so 1,000 seconds would probably be good. I'll make a note of the units. So 1,000 seconds is like 10 minutes. So because I've changed my mind, I'm modeling my milk carton, I'm going to say 1% of the volume of the milk carton flows out at the maximum rate. Yeah, when V8 is 1% flows out. Right. So somehow managed to mess up my code there. That is part of this function. Let's keep it spaced. So time end, so this is where I'm thinking about my step size now. So I'm going to say step size equals 0.1, and I'm going to say, when I say step model, let's instead of just passing the current variables, I can say pass it a step size as well, but I'll default that to 0.1. So I don't, if I want to be lazy and miss it, it'll default to that. So step size. So now I can calculate my number of steps equals, so I could say here time range equals time end minus time start. Number of steps equals time range divided by step size. So for a step size of 0.1, time range of 1,000, I'm going to have 10,000 steps. So if your computer's got a processor which is in gigahertz, that's 10 million instructions per second, I think. No, 10 billion instructions per second. So 10,000 steps should be no problem. So number of steps. So now all I need to do is say is something to store my results in. So let's say list. So we'll call it results. A is an array. Let's just call it recorded A, recorded B, C, D, and if we're going to plot that against it, we're going to have to record our time points as well. These are what I'm going to record the data in. Now I'm going to write the loop that runs the model. So for I in range, so I just want a loop that's going to cover the number of steps. So if I just want one step, this would be 1 here, but range 0 to 1, that gives me 1 run round the loop, so that would be fine. So first of all, I'll need to push my initial conditions into my recorded values here, so I can say recorded. So I could either put my initial conditions here, or I can insert them this way. So recorded A dot append the A0. Not entirely sure this is the neatest way to do it, but when I come back to look at what I've done, I think I'll do it. I think I'll understand VD0, VC0, VB0, and if you like, T is going to have my current time, so T equals 0, or in fact, to be general, T equals time start. Okay, so then I've loaded all my initial values in. Now I can start taking my steps. So all I do is say step model plug in the current values, which are going to be a list. So I can define the list in this variable's arguments, VA. So VA current equals VA0, VB current equals VB0, VC current equals VC0, oops, this equals VD0, so I'll probably define that somewhere already, hopefully. Yeah, I can just copy this list that I'm going to pass to it. So step model all these by the step size, and I need somewhere to put them. So I can just use a list to keep it consistent. So then I need to store all this data. So T equals T plus step size. And store all this into our record. And then finally, once I've stored it, I can assign the current values to equal the new values. So again, let's just see if this works. A, B, C equals 1, 2, 3. Okay, A, B, C. So a quick way to assign multiple things. And that should be that. So now I need to plot a graph. So the first time I need to do it, I need to give myself some way to plot. So from matplotlib import plot as, import pyplot as plot. So we just say, instead of import pyplot, we shorten it to this, so it just makes it a bit quicker to type. So plot.plot. Let's say recorded A against time, recorded time points, plot.show, and let's give that a go. So save, run. Step size is not defined, so I've probably called step size two different things. So sometimes I've used an underscore, sometimes I haven't. Let's solve that. So looking at this line 61 is giving me a problem. So it's always use the underline, so it's 61. Step size, that's got the underline. Step size. Save it, let's just check. Always use the underline. You see that Canopy knew I had a problem, or it will try and tell you if it spots a problem by underlining things in red. So you can see it there as well. But you see here it's underlined PLT, but that's not, oh, and that's a problem because I've left that commented. Save and run. Integer end argument expected float, so that's something that I saw a lot of people have the same error. So when we call range, if I is 0, 1, 2, 3, we can't go, we've got to give it an integer. So here, let's make sure this stays an integer. Just to keep safe as well, let's define these as floating point numbers. Just in case it causes any odd errors. Right, so seems like it ran. Let me dig out the plot and you can see we've got something that looks approximately like exponential decay,